Alright, boys and girls, today's lesson is lesson 4-11. It's called Analyzing Patterns. So we're going to talk about two different types of patterns. Excuse me. Patterns that have to do with numbers or patterns that have to do with shapes. So we're going to get right to it. This is going to be kind of a quick lesson. Give you some time to catch up on your workbook pages from yesterday. Let's go right to page 155. And it talks about patterns. And it says a pattern is a sequence that can be described by a rule. Okay? So as long as you can say the rule is for something, then that is a pattern. So for number 1, it shows you 22, 24, 26, 28, 30. The rule here is add 2. Because you're taking the term, because it says use the rule to find the next 3 terms. Okay, that's the new vocabulary here. We have pattern, but really I think term could be part of this vocabulary because each of these numbers are terms, are considered terms when you're talking about a pattern. So it says use the rule to find the next 3 terms in the pattern. Alright, well, we stopped at 30. That was the last term we used. Let's find the next 3 terms. Well, we're adding 2 to each term, so we have 32, 34, and 36. Those will be the next 3 terms. Next one. The rule is multiply by 2. So you're taking the term and multiplying it by 2 to get the next term. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. The next 3 would be, well, 40 times 2 is 80. 80 times 2 is 160. And 160 times 2 is 320. Okay, I want you to try the next 2 on your own. And then pause it and we'll do it together. Alright, so the rule here was multiply by 3. You are taking the term and multiplying it by 3 to get the next term. In this case, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 71. 81, sorry. 81 times 3, see this? I can't do mental math this morning. 243. And then 243 times 3 is 9, 12, 6, 7, 29. Okay, the next one you should have done the rule was add 7. So the first term is 2, you added 7, you got 9. You take 9, you add 7, you got 16. You add 7, you get 23. You add 7, you get 30. You add 7 to 30, you get 37. You add 7 to 37, you get 44. You add 7 to 44, you get 51. Okay, some terms are really, really easy. Some patterns are really easy with numbers. I think patterns are easy altogether because some people, they click in your head. Some people, it takes a little more to see it. This says use the rule to find the first 10 terms of the pattern. Well, the first term is 9, and it tells you to add 5 each time. So you got 9 plus 5 is 14, 19, 24, 29, 34, 39, 44, 49, let's see, 3, 6, 9, and 54. See, we added 5 to each term, and that gave us our first 10 terms. Next one, it says add 60. So I want you to do this on your own, and then we'll do it together. Alright, so it tells you the first term is 10. I want you to see the first 10 terms, so you're adding 60 each time. 10 plus 60 is 70. 70 plus 60 is 130. 130 plus 60 is 190. 190 plus 60 is 250. 250 plus 60 is 310. 310 plus 60 is 370. 370 plus 60 is 430. 430 plus 60 is 490. And one more would be 550. Okay, sometimes there's a lot of work to it, but you can add 60 to anything. I know you've been doing it for 3 years now. Alright, so here's a story problem. And that's to do with patterns. And this is where creating some kind of a grid will help you. It says Amy lives on the 20th house on Elm Street. The first house on Elm Street is numbered 3. The second house is number 6. The third is 9. The fourth is 12. If this pattern continues, what will Amy's house be like? Okay, so if you know it goes up by 3 every time, but there's also a way to see it. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So basically we're taking this number, which is 8, H, and we're multiplying it by by 3 multiplying it by 3 to get the number. So that's a way to create a variable, create a algebra problem using two variables. So we know in this case h is 20, so you times it by 3, you get 60. So it'll be house number 60. Alright, I want you to work on the next one on your own, and then we'll go over it. Alright, so it says Theo runs 5 miles every morning. He tracks his progress on a chart to log how many miles he has run in all. How many miles will Theo write on the 100th day? Well, we have this big chart here. And instead of going all the way and adding all the way to the end, you can find an algebraic problem here. Okay? 1 turns into 5. 2 turns into 10. 3 turns into 15. If you understand what it's doing each time, it's taking D and it's multiplying by 5 to equal M, the miles. Day times 5 equals the miles. So knowing that, on day 100, you multiply by 5 to equal 500. So it'd be 500 miles. Alright, so we're going to go to the next page, and this has to do with patterns and shapes. I think this is the easiest, but some of you might find it a little tough, so it's no big deal if you do. Okay, so what I do when it comes to patterns with shapes, I'd say them in my head, but I kind of say them in a song not really a song, but like a rhythm to know when I get to the next one. So if I go white square, black square, white square, black square, black square, white triangle. White square, black square, black square, right, white triangle. That tells me that I need white square, then I need black square, white triangle. Okay? And that's what I would say. In here I would say white square, black square, white triangle. Okay? White square, black square, white triangle. That's what I would say. So it says, what will the 10th term be in this pattern? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would be a black square. What will the 15th term be in this pattern? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're at 12. Let's see what would be next. We have a white square, 12, 13, 14, 15. So once again, it'd be another black square. For patterns that grow, the next one down, how does each figure in the pattern change from one term to the next? These are considered terms too. That's a term, that's a term, that's a term, that's a term. How does each figure in the pattern change from one term to the next? We go from 2 and we double it to 4. We go from 4 and we double it to 8. We go from 8 and we double it to 16. So you could say the term is being doubled, or you could say the term is multiplied by 2. Okay? 13. Describe the number of squares in the next term of the pattern. Well, we're still back up. Okay, the number of terms, well, we have 16 here. We know it's times 2, so it's going to be 16 times 2, which equals 32 squares. Next one. How does each figure in the pattern change from one term to the next? It goes from a full circle to a half circle to 4 to 8. So what's going on each time is the number of equal parts doubles each time. Here we have 1 equal part, we double it to 2 equal parts. 2 equal parts double to 4 equal parts. 4 equal parts we double to 8 equal parts. So the next circle would have 16 equal parts. Okay, well, that's not the question. That's not the question. So, how does each figure? On here, we could put the number of equal parts doubles. And then it says, how many equal parts would be the 7th term? Well, we know we go from 1 to 2 to 4 to 8 to 16 to 32 to 64. So that means 1, 2, 3, 4, 5, 6, 7. So it'd be 64 parts in the 7th term. So patterns with shapes and numbers are really easy as long as you really focus on it. So now, because there's no more in this lesson with patterns, I want you to continue and work on the pages yesterday. We never finished with the prime, composite, and factors and multiples.